Okay, so today we're going to start with chapter 19, environmental chemistry, water. So we're just going to begin here with the water cycle. You don't really need to know this for Leaving Cert, you wouldn't be asked it, but all of nature, it's very important that we can recycle all our nutrients. You see it in biology, where you have your nitrogen cycle and your carbon cycle. And it's very important that nature can do this, otherwise we would end up running out of our natural resources. So what we have here is we have evaporation. There's three kind of really big ways in which water is released into environment: evaporation, respiration, and transpiration. Evaporation is when the sun's heat causes the water in our oceans and our rivers and our streams to evaporate. As our water evaporates, it's going to cool, and when it cools, it condenses, and it condenses into tiny droplets of water, and these gather by clouds. Those then are pushed along by the wind, and when they're pushed along over high ground, they're going to end up becoming too heavy. Further cooling occurs, and it drops. You end up with your drops of rain. It doesn't always have to be rain, obviously. It can be snow, hailstones, and all of those are generally called precipitation. It's then going to run off into your streams and into your rivers. Some of the water is then going to be diverted into reservoirs, and it's going to be treated in order to be used in homes and industry. And we're going to be looking at this process in more detail. And what we have then, once the water has been used, it's treated in sewage works, and then it's returned to the rivers and the seas. Again, we'll be looking at how water as well is treated here. Okay, so this is our water cycle. Just a couple of points on water. These are kind of things we know already. It's a good solvent, so it dissolves in lots of different substances, and many other substances dissolve in it as well. It is also a polar substance, okay, so it's polar covalent, and we've looked at that in a little bit of detail in our last chapter in organic chemistry. We will be looking at chapter 5 after this chapter. Basically then we've two types of water. The first type of water that we have that we're going to look at in a bit of detail is hard water. And you need to know the definition for hard water. And hard water is water that does not easily form a lather with soap. And what it does is it forms a scum instead. And I'll actually send you on a difference in a video on YouTube as to the difference between hard and soft water. Obviously soft water is going to form a lather easily with soap. A lather is another way for suds, okay, but when you're describing it, please describe it using a lather, okay. It is only caused by two types of ions, Mg2 plus and Ca2 plus ions. So only those two types of ions cause hard water. If those Mg2 plus or Ca2 plus ions are not present, you will not have hard water present. And you need to know what is the substance. Now, calcium hydrogen carbonate is obviously what causes the Ca2 plus ions. Magnesium hydrogen carbonate would be what causes Mg2 plus. In general, just for your own knowledge, I suppose, Mg2 plus is in areas where you'd have dolomite rock, and that would kind of really be up and around the north. We more have limestone down here, so that's where we have our calcium Ca2 plus ions coming from. So it's caused by calcium hydrogen carbonate. And what I'm going to look at in the next video is how this calcium hydrogen carbonate comes to be in our water. Just going to fly through one other slide before I do that. So hard water is water that does not easily form a lather with soap. So it forms a scum instead. There is advantages and disadvantages to hard water, okay? One of the biggest disadvantages is that it wastes soap. How does it do that? Because firstly, instead of my soap actually reacting with the water, it firstly has to react with these calcium Ca2 plus and Mg2 plus ions. So what happens then is that you're going to end up using all of the soap here to react with all of the calcium and magnesium ions present. But only once all of these are gone will you then end up with your soap actually forming a lather. So you're wasting a huge amount of soap here, particularly if you're in an area of very hard water, okay? So what you end up forming is basically a scum, okay? And only when all of those those calcium and magnesium ions have reacted will you then end up with a lather. You don't need to know that equation, but it is just there to show you how soap is wasted when I use up my hard water in order to react with my calcium and magnesium ions.